All right, today's video is on combining like terms. We've been talking about algebraic expressions, so they have variables and exponents. And sometimes you want to simplify an expression because it has more than one variable. So we need to understand what like terms are. So let me give you a real world example here. Let's say that your mom is going to McDonald's, so she asks you and your brother what you want. So you might say, well, I want 2 cheeseburgers, some fries, and a drink. But your brother just got finished with football practice, so he wants 3 cheeseburgers, 2 fries, and 2 drinks. So if you look at this in algebra, if we were going to do this, we might write this like this. 2b, so 2 burgers, plus a fry, that stands for my F, a drink, and then your brother wanted the 3 burgers, 2 fries, and 2 drinks. Okay? But couldn't we also write it like this? Couldn't I combine my burgers together? So I've got 2 burgers here and 3 burgers here. So isn't that just, isn't that just 5 burgers? And then my fries, couldn't I combine those together? So I have 3 fries, and I could combine my drinks together. So I want a total of 3 drinks. 3 drinks. All right. So that's just combining like terms. I'm combining the things that are similar. All right. So here's one more example. If we have 2 apples here, 3 bananas, and 3 more apples, I can just simply combine my apples together. That's a total of 5 apples and my 3 bananas. Okay, so don't let the variables confuse you. If they are the same variable, then you can add them together. So let's go ahead and look at your notes now, and let's write down the vocabulary for what a like term is. A like term are terms that contain, here we go, the same variables raised to the exact same powers. Exact same powers. All right. So here are some examples. So 5x and 8x, they are like terms because they have the same variable. They have the same variable. So I can easily add those together. So 5x and 8x is just going to be 13 x's. Just like if I said 5 xylophones over here and 8 xylophones over here, altogether I would have 13 of them. Okay? 3xy, see how they are xy and xy? So they are the same. So I can add them together. So I have a total of 8 xy's. And over here, x squares, they're together. So I have a total of 8x squares. Okay, exact same powers. Now, if I wanted to add 6x squared and 5x, I could not do that because they are not raised to the same power. They're not raised to that same power. Okay, so go ahead and pause the video and write down that definition and the examples. All right, one more side note here that I want to talk to you about is if you notice these, do you see this x plus x plus x plus x plus x plus x? My question is, how many x's do I have? I have 1, 2, 3, 4, 5, 6 x's. I have 6 x's. That's just like saying if x is my pencils, I have 1 pencil, 1 pencil, 1 pencil, 1 pencil, 1 pencil, and 1 pencil. So I have a total of 6 pencils. So if I'm adding my variables, I'm simply going to see how many variables I have and put that coefficient in front. Okay. Now, different. If I am multiplying my x's, if I'm multiplying my x's, this is where I'm going to use my exponent. Okay, so these are very different. If I add, I'm simply going to have a coefficient in front. But if I multiply 1, 2, 3, 4, 5, that's going to be an exponent. All right, so if you think about this, let's just say my x is 2. Okay, if my x is 2, 2 plus 2 plus 2 plus 2 plus 2 plus 2 is just going to be 12, which is the same as 6 times 2. But if my 2's were here, 2 times 2 times 2 times 2 times 2, that's 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So aren't I doing exponents there? All right, so that's 2 to the 5th power means 2 times 2 times 2 times 2 times 2. All right, so what you need to know in this situation, again, is if you're multiplying your variables, you're going to come up with exponents. If you are adding your variables, you're going to have a coefficient in front of that variable. All right. Okay, so let's look at your notes again. All right, I want you to look at each pair, and I want you to decide if you think they are like terms or unlike terms. So I'll do the first one with you. Sorry, the little squiggles here. I just copied it from your notes, so you don't have it on your notes. So 3x squared and 4xx. Okay, xx right here means I'm multiplying my x's together. So wouldn't that just be 4x squared? So now are they the same? Yes, they are alike. All right, so go ahead and you circle like or unlike, pause the video, and then come back and check your answers. All right, check your answers. All right, make sure on this one you saw there were two x's here, so x squared, so those were alike. These, even though the order x, y are different, they are still alike. It's one x and one y. This one has a variable, this one doesn't. That's why they're unlike. If you don't understand why I circled some of these, please make sure you ask me. All right, let's move on. You don't have this on your notes. We're going to do this together. All right, so we are going to now combine like terms. So let's do them together. So first of all, when you see a problem, you need to kind of look and see which ones are alike. So I know these two are alike. So that would be 15, and there's nothing to add this one to, so it's just plus 8. This one, 7c's minus 3c's is just going to be 4c's. Let's see, my Q's are alike. So 5Q and 9Q, that's just 14Q's minus 8. All right, let's look at this. Okay, here's my H's. So this is a little different. Look at this one. So basically I have minus H, 9H's, so that's kind of a negative, and then a positive 4H. So a minus 9 and a plus 4, that's just going to be a total of 5. Okay, so kind of think of it on the number line, and minus 9 on the number line, and then you add 4, that's going to be a plus 5H, and then my 5 plus 8 is just 13. And you can put that 13 in the front or the back, either one. All right, and on this one, we've got my D's together, 8D minus 7D's, so that's just 1D, and then 9 minus 3, that's so that I have minus 6 left, because if I have 9 positives and I take away 3, then that's 6. That's gonna be plus 6. Okay? All right, and then if I have 9B plus 3B, those are my B's, so I just have 11 B's, 12 B's. Sorry about that, 12 B's. Okay? All right, let's have you look at a couple. So this is what I want you to do here. I want you to match these expressions over here with a simplified expression. So obviously not all of them are going to be used. So I want you to simplify them and see which one of these will work. Go ahead and pause the video and match them up. You may use these more than once. I don't know. We'll just have to see. All right, pause the video and go ahead and simplify these expressions. All right, go ahead and check your answers. So actually, 3 of them were none of the above, and just 2 and 3 were C and B. So look at my answers and see if you came up with the same simplified expression. Okay, if you have some issues with those, especially with these last 2 here where you had to do some subtracting, please make sure and ask me tomorrow. Okay? All right, here's your video exit slip. You've got 5 questions. Make sure and do that on your notes page, and I will check it tomorrow. Have a great day.